problem I decided to do was to sketch the graph of the equation y equals x divided by 1 minus x squared. So first, before you find the first derivative or anything, you find the domain, which in this case, since the bottom, like where the bottom would be 0, would be negative 1 and 1. The domain would be negative infinity to negative 1, and then negative 1 to 1, and then 1 to infinity, and then you'd find the asymptotes, which would be where the domain isn't. So it would be x equals negative 1 and x equals 1. And then for the horizontal asymptotes, it'd be, since this equation is bottom heavy, meaning that the equation on the bottom, the highest exponent is greater than the highest exponent on the top equation, the horizontal asymptote is y equals 0. So then, for the equation, we have to find where y equals 0 and where y does not exist. And for y equals 0, it'd be x equals 0. And for the does not exist, it'd be 1 minus x squared equals 0. And then if you do some algebra, you get x equals plus or minus 1. So then once you have those numbers, you would make one of these charts, and you use the factors here, and then the numbers that you just found right here. So it would, for less than negative 1, x would be negative, and between negative 1 and 0 would be negative, between 0 and 1 positive, and greater than 1 would be positive. And then for less than 1, or less than negative 1, 1 minus x squared would be negative, positive between negative 1 and 0, positive between 0 and 1, and negative between 1 and 0. So that means that it is positive between negative infinity and 1, and 0 and 1, and negative between negative 1 and 0, and 1 and infinity. And then you would go and find the second derivative. So, or the first derivative, I'm sorry. And then that would be 1 minus x squared minus x times negative 2x all over 1 minus x squared quantity squared, which is equal to 1 minus x squared plus 2x squared all over 1 minus x squared quantity squared, which is equal to 1 plus x squared all over 1 minus x squared quantity squared. And then you would find where that is equal to 0 and where that does not exist. And it'd be equal to 0 where 1 plus x squared equals 0. And if you try to solve that, you'd get x squared equals negative 1, which obviously doesn't, it's not a real number, so that can't happen. And it doesn't exist at 1 minus x squared quantity squared equals 0. And then if you do algebra, you find out that x equals plus or minus 1. So you do the same thing that you did for the first equation, and you make one of these charts using, the factors that you got and then critical numbers that you just found. So for less than negative 1, both the factors are positive. Between negative 1 and 1, both of them are positive still, and between 1 and infinity, both of them are positive. So the derivative as a whole is positive less than negative 1, positive between negative 1 and 1, and positive when it's greater than 1. So this means that it is increasing for the whole thing, but since there's those asymptotes at negative 1 and 1, there's like pauses there, so it'd be negative infinity to negative 1, negative 1 to 1, and 1 to infinity. So then after that, you would take the second derivative, and that equals 1 minus x squared, quantity squared, times 2x minus 1 plus x squared times 2 times 1 minus x squared times negative 2x all over 1 minus x squared to the fourth. And then if you do some factoring, you get 2x times 1 minus x squared times 1 minus x squared plus 1 plus x squared all over 1 minus x squared to the fourth, and then this cancels out with one of these, so then you get 2x times 1 minus x squared plus 1 plus x squared all over 1 minus x squared to the third, which equals 2x times 2 all over 1 minus x squared to the third, which equals 4x over 1 minus x squared to the third. So then, for a regular equation, you would try to find, you would do the second derivative test where you take all the critical numbers from the first derivative that equaled 0, that made the equation equal 0, to see if there was a maximum or minimum. But since there was no critical numbers that made it equal to 0, then there isn't going to be a maximum or a minimum. So from there, we just find where it's equal to 0 and where it does not exist. And that's equal to 0 when 4x equals 0, so just x equals 0. And then it does not exist when 1 minus x squared equals 0. And then if you do algebra, you get x equals plus or minus 1. So then you make another one of these charts, and for negative 1, or less than negative 1, 4x is negative. Between negative 1 and 0, it's still negative. Between 0 and 1, it's positive, and greater than 1 is positive. And then less than negative 1, 1 minus x squared to the third is negative. Between negative 1 and 0, 1 minus x squared to the third is positive. Between 0 and 1, 1 minus x squared to the third is positive, and greater than 1, 1 minus x squared to the third is negative. So the second derivative as a whole is positive, less than negative 1, negative between negative 1 and 0, positive between 0 and 1, and negative between 1 and 0. So from that, we know that it's concave up between negative infinity and negative 1 and 0 and 1, and that it's concave down between negative 1 and 0 and 1 and infinity. So then we can put all of them together down here, and from the first equation telling us that it's increasing, or that it's on top of the x-axis, the first derivative telling us that it's increasing, and the second derivative is telling us that it's concave up. We know that from negative infinity to 1, it's going to have this shape, and then from the information that it gives us, from negative 1 to 1, we know it's going to have this shape, and then from 1 to infinity, we know it's going to have this shape. So then if you actually graph it, it's going to look like this.